This video will help you to understand how to construct an angle bisector. To construct an angle bisector, we are going to bisect, in this case, angle x. To do this, we're again going to tie it to the properties of the rhombus. In a previous video, I went over the multiple properties of a rhombus. Besides the definition, all four sides are equal, there are multiple properties. Opposite sides are parallel, opposite angles are congruent, diagonals bisect each other, diagonals are perpendicular to each other, and the diagonals bisect the angles of the rhombus. In order to construct an angle bisector, we're going to use this last property. The diagonals bisect the angles of the rhombus. So to do our construction, we're going to make a rhombus, because if it's a rhombus, the diagonals bisect the angles. So to begin, I'm going to construct a rhombus around this given angle. Now the definition of a rhombus is 4 equal sides. Right now I have 2 rays, which means I don't have any side lengths. I get to choose whatever I want. So set your compass to some length. It's arbitrary. Pick what you want. Make sure it's not too small, not too big. It fits the picture. And I'm going to find where this circle intersects both rays. I'll mark this. I'm going to call them A and B. Now this is 3 vertices of the rhombus. A, B, and X. I need that 4th vertex. The way I'm going to do that, I'll take the same length as before, XB, and I'll draw the same circle congruent to it, centered at A. So centered at A, somewhere up here. And pick the same radius, and we're going to draw one centered at B. Now where those 2 circles intersect, we're going to call point C. I know this is a rhombus because AX has the same length as BX, has the same length as AC, and has the same length as BC. Because all 4 sides are equal, it's a rhombus. Now the way that I'm going to construct my angle bisector is I know that if I have a rhombus, the diagonals bisect the angles. So to finish up this construction, we're going to draw in the diagonal that goes through angle X. So if we connect C to X, there's the diagonal, and it's going to bisect angle X. Bisect means to cut into 2 equal pieces. So this angle up here, BXC, will be equal to the angle down there, AXC. So this is the construction of the angle bisector. CX will bisect angle X into 2 equal parts. I want you to try one now. So I've got angle X down here. Go ahead and draw a picture similar to this one. And then when you're ready, pause the video, do the construction, try it at home, and when you're ready, resume the video. Check your answer. I'll give you a minute to be ready. All right, hopefully you've had a chance to do it on your own. So again, I get to choose any arbitrary length. So this time I'm going to set my compass to this, and I'm going to set the length of the rhombus. In this case, XA and XB are going to be the side lengths of my rhombus. I know they're equal, XB and XA, because they're both radii of the same circle. To find the 4th vertex, take the same radius as the original one. Draw one circle centered at A, and one circle centered at B. Where they intersect is going to be that 4th vertex. Now there's multiple overlaps, and some people get confused as far as which is which. You need to find the one that is the same length from both corners. Like this one, for instance, is the same length as from A, but if you try going to B, you're going to see it's too short. So it's not this one, it's not this one. It's the one where the lengths are all equal. So BD, or well, BC rather, we'll call it second C, is the same as AC. So this is the one I want. So there's my 4th vertex. So draw the rhombus, and then draw on your diagonal. There's my angle bisector. Angle X is cut in half, so the angle AXC is congruent to angle BXC. So when I highlight, I'm going to highlight the angle bisector, and highlight the fact that we've got the 2 congruent angles now. All right, thank you for watching, and I hope this helps you understand how to draw an angle bisector.